Hi everyone, welcome to the second video in the new team's Onshape introduction series. In this video I'm going to be going through some of the tips that I've collated that pertain to part studios in Onshape. As I've said in the past videos, we'll be assuming that you've watched all the required learning pathways and courses from Onshape. I can't go over the basics in this video. I'll just be covering the things that I thought were notable, difficult, or tricky to get used to after using Creo. With that out of the way, I'll start rattling off my tips in the order that they happen to be written down. So part studios are for creating geometry, exclusively for that alone, as geometry cannot be created or modified from an assembly. As such, we should never see two of the same part in the same part studio. If two of the same part appear in the same part studio, you created multiple versions of that part rather than multiple instances of the same part in an assembly. Some of you may see a glaring issue with the inability to modify geometry from the assembly level instead of the part level, as we do that quite a lot with top-down modeling. Onshape does have the capacity to do assembly level modeling, but it's referred to as in-context modeling. I'll be making a separate video about that, so don't worry about it for now. Okay, so here we are in an actual part studio, and I'll rattle off some tips about sketching first of all. I'll start off with some general tips, and to do that I'll jump into one of our sketches here, so I'll double click it in the model tree, and you'll notice that by default it doesn't snap to viewing normal to the sketch plane like our particular Creo configuration does. So to get around that, just press the N key to view normal to the current sketch. Awesome. Alright, so one of the tips that I wanted to give you was about sketch geometry versus construction geometry. So that you can see these exterior lines here are all solid, which means they're real geometry, and these lines here are dashed, which means they're construction. So in essence, the only difference between these ones are that real lines are used to make sketch loops for extrudes and revolves and all that sort of stuff, whereas construction geometry gets it totally ignored by that. So once you already have geometry that already exists, you can toggle it between real and construction by selecting it and then hitting the construction button up here. Alternatively, you can use the Q keyboard shortcut, which I use quite frequently. So you can see I can toggle it back and forth there. You can also preemptively select it before drawing lines. So I've selected it there and that line comes out as geometry. Very good. Once again, I can also then select that line and convert it back and forth if I need to. The next tip relates to the Use tool, which is this one here. So depending on kind of what environment you're in, sometimes when you're doing a sketch in Onshape, it will or won't let you snap to geometry outside of your sketch. So you can see right here, I'm in the same part studio, so it will let me. Sometimes it won't though. That being said, it's potentially useful for me to grab this entire line, either as construction geometry or as real geometry. For now, I'm just going to use construction geometry. I can click that line and you can see that line then gets projected into my sketch as construction geometry. So this is in essence basically what it was to add references in Creo. So in Creo, you could add references from anything outside of your sketch, and then you're able to snap to those things when you're drawing other lines and that sort of thing. Alright, so for the next tip, I've actually brought us into one of those in-context relationships that I was talking about before. So this is a part studio, but I've used an assembly context here just to kind of demonstrate a bit of a point. It's not really that important. The only thing to note is that none of these parts are actually from this part studio. Anyway, so if I go to sketch, I can select one of the context faces as a plane for sketching. I'll hit N to view normal, and you can see it's kind of shaded that purple to be like, this is the face of which you're sketching on. Anyway, so if I then draw some geometry, not really important what it is, and I accept that. If I then want to extrude that sketch face, and I try and select it, you'll notice that it actually kind of uses whatever your original sketch face was as a bit of a reference, whether you want it or not. That can get very frustrating. Right now, it's pretty clear that I can just select it and I get what I wanted. However, if you're doing things like lofts, then I don't believe you can have internal closed loops as well as external. So the way around this, I'll hide that sketch for the moment, is just to add a plane, an external plane, on whatever surface it was that you wanted to use. So I'll set that to have an offset of 0, Excellent. I'll bring my sketch back, and then I'll change what sketch plane my sketch is on to be our plane that we made. Excellent. So now I can extrude that shape without any issues, without it involving the context face. Alright, so now we can start getting into some of the drawing related tips for Part Studios. So if I go into this drawing here, I'll delete what we did before. So the first tip is about drawing lines. So by default, if you just left mouse button without holding in while you're drawing lines, Onshape will assume that you're trying to draw a multi-segment line like that. If you decide that you actually want these lines to be disjointed, I thought that you basically had to either click on the tool again to escape it, or press the escape key, click on it again to then start drawing another line, and the process continues while you're trying to draw other lines. That's pretty painful. The solution to that is you can either click and drag while you're drawing a line, or if you've started drawing a line and you forgot to start dragging, you can basically just double click on the end of that line and you won't draw a second line segment, and you can continue going. Another drawing tip is if we go into a sketch here, you may have noticed that you can't actually set two dimension values to be the same. So if I try to dimension these ones here, in Creo, I would be able to grab an equal constraint and apply it to the actual numerical values here, which I can't do that in Onshape, and honestly it's kind of illogical that you could in Creo. The obvious approach is to just make the line segments themselves equal. Obviously that's a bit over-dimensioned. Cool. So that's one approach for it. That's not always accessible though. For example, if I've got kind of a nested square here and I want to say that the distance between the inner and outer edges of these two squares should be the same all over, that's obviously not something that I can do very easily. The approach for that is to use some construction geometry, like so. Wonderful. And then I can actually set those two construction lines to be equal and dimension them as needed. The potentially smarter approach, if you're using certain dimensions all over the place and you need to set a whole bunch of things equal to that dimension, is to use variables, which I end up talking about a little bit later on in another video. The last few tips for sketching, something that's pretty useful to be able to do is to change the sketch plane that you're working from. So at the moment I'm working from that plane 6 there. If I want to change that, I can just go back into this box here and select any other plane that I'm interested in, just like that. Alright, so now I'll start talking about using constraints in Onshape sketches. So if your sketch ever has blue color in it, that means that something is not fully defined or constrained. Usually that means that it's missing a dimension or a constraint like vertical, horizontal, coincident, or equal, or something like that. Generally speaking, you should never leave a drawing with undefined geometry in it. It means that it could be fairly unstable. However, sometimes it can be somewhat unimportant. If I'm just trying to make a mirror plane here to mirror this geometry about, I don't really care how long this line is. I do care about how far away from that thing it is. So I can now select all of that. I can mirror it about my line there. And even though I've still got this little blue dot here, it doesn't really matter because this piece of geometry, the length of this line, is unimportant for my design intent. Second useful tip is you can hold Shift while drawing to avoid snapping to things. And this is the same as it is in Creo. So if I wanted to get close to that line segment without it snapping, I can just hold Shift and then Onshape won't let it snap to any geometry that's nearby. Another useful constraining tip in Onshape is if you want to apply one constraint to multiple things without having to go back in the tool. So I can select a bunch of these and set them to be vertical, and you'll notice that instantly after it applies that constraint, it jumps out of that tool. So I then have to select things again. Alternatively, I can pre-select the tool and then go through and select everything that I want that constraint to apply to, and it'll keep going indefinitely until I exit out of that tool manually. Something else you should know is that by default, sketch constraints aren't shown while sketching. you can use the show constraints tool up here to show them. White constraints basically just say that these constraints apply only to things in the sketch, whereas blue constraints say that I'm referencing something from outside of the sketch to provide this constraint. Something else that tripped me up when I started was that horizontal and vertical lines, vertical constraints are actually dependent on the orientation of your sketch. So if I go through and delete all of these, you can see now that if I apply a vertical constraint, it's pretty logical that exactly that would happen. If I rotate this sketch 90 degrees, these all seem horizontal. If I try and apply a horizontal constraint to these, it actually snaps to what seems to be vertical, and that's purely just because Onshape uses kind of a persistent perspective throughout all of its sketches, so it doesn't matter what way you're looking at this from, it'll always do it relative to the view cube. The final tip that I'll give you for providing constraints within Onshape is if you start drawing something and then immediately start typing. So if I type 100, you can see it applies a 100 mil constraint to that line. And this applies for things that have more than one dimension as well. So if I draw a rectangle, click to accept, I can start typing 50 and then 100. The first dimension will always apply to a horizontal constraint and the second will always apply to a vertical constraint. Alright, so the next tip that I've got is actually quite a fundamental thing that I found was very underutilized when we were using Creo, and that is to use the second end position setting in an extrude. So I can grab one of my closed loop sections here and I'll say 25 mils, happy with that. I can then also check this button that says second end position, and that means that it can go out in the second direction. This obviously looks very similar to symmetric, except this way you don't have to have it to be an equal length from the sketch plane. So I can do second end position and then go 50 millimeters, for example. You can do some pretty powerful stuff. If I set that to be 10 millimeters and flip the direction, you can kind of see that it's made a 25 millimeter extrude from the sketch plane where it's adding material, and then the second extrude, which is only 10 millimeters deep, is then removing material. So you can also achieve this by using a whole bunch of planes and everything like that, but this is a nice, neat way that I've used quite a few times when building the accumulator. So a little tip that I'll give you is that you don't actually have to extrude only from sketch faces. So I can grab a face that hasn't been defined by a sketch, such as this one down here, and I can use that as my extrusion. Right up here, we've got the Boolean options. We'll touch more on kind of what Boolean options mean in Onshape later, but they're really important to understand that these are basically what facilitate us to have multi-part modeling within the same part studio. So instead of adding material to my method pin here, I can go new, and it'll save that as a new part that I can see in my instance list down there. These other options are all fairly self-explanatory. Add, I get to add it to that thing there. It's quite useful to do merge with all if you're trying to consolidate a lot of parts into one. It's not common, but it does happen. Remove is once again pretty self-explanatory. It just removes material from whatever is in your merge scope. So at the moment you can see that the method pin is in my merge scope, and if I remove it, it's going to throw an error because I'm not trying to remove material from something. The last one is intersect, which is a little bit more complicated. It basically just only keeps the sections of volume where both parts exist, but it's not very commonly used by me at least. These options all appear in the Extrude, Revolve, Loft, Mirror, and Pattern tools. They're a pretty common concept across all of Onshape, and it's something that you should definitely get used to using. So for the next tip, I'll make another extrude on top of this external cylinder. I'll add it as a new part as well. So now we've just got two of those cylinders. This tip relates to this little final button down here. So this basically shows what the effects of the changes that you're doing are. So if I change this to be, I'll say 10 millimeters, so I've just reduced its height by 15 millimeters, I can say final, and it'll show me that this secondary tube that I just made has been adjusted for that change there. So the next couple of tips pertain to using the Revolve tool in Onshape. So usually when you're using the Revolve tool, you'll have a sketch that looks something like that with a pretty clear axis of rotation defined. So if I wanted to revolve this now, I can select that loop and I can choose that axis there. Alternatively, it doesn't actually have to be a construction line. It can just be any line that exists in the plane that you want. So if I once again go to Revolve that section, I can choose that line, which is not a construction line, but it just exists and it's in the right place. Another way that you can choose a revolve axis, if I just do a sketch on the front plane, and I'll just revolve something like that. Excellent. So then if I go to revolve, I can choose that profile, and I can actually just choose the axis that is defined by any cylindrical object. So I can choose that there, and it kind of infers the correct axis for me to use. So the last interesting tip about revolves is how you can use the dimension tool when you have a construction line down the middle. So if I just dimension these as normal, you can see we get a 6.5mm dimension there, which is fine. However, since this is going to be a revolve, it can actually be fairly logical for me to want that as a diameter instead. So if I've used a construction line, like I have down the center line there, and I take this dimension beyond that construction line, you can see it actually uses a diameter dimension instead of a radial one. The next couple of tips that I'm going to show you relate to the Loft tool in Onshape, which is just the equivalent of the swept blend tool in Creo, if you're familiar with that. So you can see I have a bunch of profiles in front of me. I want to make a loft between all of those. So these bottom three should be quite easy. They're all rectangles. You can see that it just goes from one profile to the next. That's pretty nice. Those of you that use the swept blend tool in Creo will recognize that this next one shouldn't work because all of these shapes down the bottom have an equal number of vertices, which is 4 for all of those, whereas the circle appears to have none. Onshape is kind of clever and it can work it out for you. However, you don't have a whole lot of control over how this flows, and so just leaving a circle without defined vertices is not a good idea. So to address this, I'll go into my circle sketch and I'll grab the split tool, which is usually found in the drop down underneath the trim tool, and I'll add in a bunch of points here. Now obviously you guys should be very carefully constraining these points for where you want them to lie on your circle. Excellent. Now if I want to make a loft between all of these, I can grab the bottom three, once again, pretty easy. And I can grab the circle as well, and you can see that our loft lines have gone to the vertices that we defined. So that's fine, but where this becomes very powerful, like why you actually really want to define these vertices here, is so that you can set which points flow to which. So you can see on these bottom two here, it's defaulted by choosing this corner and this corner to flow into each other, but maybe that's actually not what I want. Maybe I want this thing to rotate. So I can do match connections, and I can grab corners going around the circle here. So you can just see it's all pretty nice. And then it makes that beautiful twisting shape. This gives you a lot more control and flexibility over your lofts. So next up, I'll talk about variables. Our team's CAD has, historically speaking, painfully underutilized whatever CAD system has been made available to us. Variables, either in Creo or Onshape, allow you to parametrically control your CAD models. It's something that we haven't been very good at using, but we can definitely change that. So to use a variable in Onshape, all you have to do is select the variable tool up here in the Part Studio. I can set that to be something called copper bus bar thickness. You can choose whatever name you want here, and then I can set it to be 4mm. So obviously the units matter down here. It's related to these up here, but I'm sure you'd know that from watching the learning pathways. Anyway, so now that I've set that, I can use that variable either in sketches or in extrudes. Basically anything that uses a numerical value in a Part Studio, I can use that variable in. However, it matters where it is in the model tree. So if I wanted to use this variable in any of these features here, I'd have to drag it up above them. Anyway, so now that we've got that variable, I can do an extrude of these two sketches here. Wonderful. And I can set that to now be the variable that we set before. So you can see they both came out to be 4mm. So you can see where this becomes really powerful, because if I decide that 4mm is not the right value that I want, I can go 2mm, do final to see a bit of a preview. I can change it to anything that I want or need, and it'll result the right way every time. You can also perform some mathematical operations on your variables as well. So I can now create another variable and call it, I don't know, bus bar gap, and I can set it to be 1.1 times the copper bus bar thickness that we set just before. And as soon as I do that and go OK, you can see that it's come up at 4.4 millimeters. So you can involve multiple things here. You can see up the top I've got another variable called spacing something. So I can get this one and go divided by spacing. Cool. Excellent. So you can do quite a lot of different things in here. It's a really powerful tool, and I highly recommend getting familiar with using variables all the time. They're fundamentally one of the most powerful tools we can use to maintain a robust CAD model, and they're really easy to use once you start remembering that they exist. So an issue that some of you might have seen with the way that we've been using variables so far is that they'll only apply to the part studio that we're currently in. So for example, these bus bars here, if I wanted to have some other bus bars somewhere else in this document that were the same thickness as this, I wouldn't be able to parametrically control that. I would have to go through and manually update it every time I change these ones as well. We have a solution to this, and it uses something called a FeatureScript, and you can see I've inserted this FeatureScript up the top here from my menu up here as well. It's called parameters there. So this is a feature script that I made for the accumulator, and I'll show it to you just here. So in this feature script, you can see I've set some of these variables to be equal to certain values that I want to use in a few different part studios at once. So as long as I insert this feature script into any part studio that I want, I can use any of the variables that are in here for that part studio. You can perform some mathematical operations on the variables as well. So you can see I've got a fairly simple example down here, setting the segment width for the accumulator. I'm pretty sure there are some more complicated operations that you can do in here, but I won't get into that for now. But in general, this is an extremely valuable tool, which almost every single document should be using. It's almost guaranteed that some parts across different part studios will use the same logical value, and relying on you or the next person to remember to update every instance of that parameter is really poor CAD, and it's how things kind of fall apart and just get out of date. I forgot to mention it while I was recording this video, but I do go into the parameters feature script in a lot more detail at the end of this series. So don't stress about fully understanding it now. I will get to it a bit later on. Patterns are something that can save you quite a lot of time in Onshape and make your model quite robust and parametric. There are a few considerations that you should be across before you dive headfirst into using them though. So generally speaking, we've got a few different types of patterns. We've got the Part Studio pattern, we've got sketch patterns, and we've also got assembly patterns as well. Of those, usually you'll always see linear and circular patterns. Occasionally you'll see curve patterns as well. They're much less common, and I'll let the Onshape learning pathways discuss those ones because they're fairly complicated. Alright, so if we're now going to make a patternable feature, I'll make an extrude from that circular face. I'll remove material, and for now I'll go through all. Wonderful, so we've got a hole. Now if I wanted to pattern that hole, first thing I could do is go linear pattern, and I'll go feature pattern first of all, generally one of the simplest ones that you can do. I'll pattern the extrude 6 feature, and as for a direction, I will grab that edge there. I'll say we've got 3 spaced, I don't know, 130 mils apart. Beautiful. All right, so that's one way of skinning the cat. You can use this performance manager here to show you kind of what things take the longest amount of time. That's how you can kind of discover if you've got a model that's really slowing down your computer. You can kind of have a look and see what's going on in there. Generally speaking, the feature pattern is not very fast. It's fairly computationally intensive depending on what the feature is. If possible, you should always use face pattern. Face pattern, you basically just grab the faces that you're interested in, and a lot of the time Onshape can kind of work out what you want to do. Sometimes this won't work. It really just depends on what geometry you've got. Another really important thing to note is the direction. So you can see before, for the direction, I just grabbed the edge there, which works for us now. But if I was to significantly change this model or make changes to that edge, this reference might die and it may not work anymore. So one of my favorite ways to define the direction is actually using the datum planes. So whatever datum plane you select, the pattern direction will go normal to that direction. So you can see grabbing the right plane, it gives us the same pattern that we were after before. Just quickly, before I jump off of this type of pattern, if you are doing the feature pattern, you may need to click this apply per instance. You should try and avoid doing it because it does slow things down, but sometimes it may not work without it. Generally speaking, you should never need to use the part pattern within a part studio because having more than one instance of a certain part in a part studio is not what we want to do. But it can be useful for when you're trying to pattern a part and then you're going to bridge them later using some other geometry. So those are some of the decent ways that we can get that pattern there. If we wanted to do something slightly different, I'll go into my sketch here and I'll actually make a sketch pattern. Sketch patterns are one of the worst ways that you can do these, generally speaking. They are kind of slow, really slow down your model. They work and you can do some fairly interesting things with them. So you can see I've got that pattern there and I could grab all of those. One place where these do come in quite handy, I can delete that dimension there. I can draw some construction lines out to these entities here. Oh, that one is meant to be horizontal. Wonderful. And then I can actually set these end lines to be the same distance. So then these are actually the same distance from the edge regardless of what I do with this pattern. So that's one place where a sketch pattern can be reasonably powerful. However, there are other ways to do this that don't require you to use a sketch pattern as well. Some of the most useful tools that you can find in Onshape are the Boolean tools, which are up here in the toolbar. So you can see I've got two parts here. One is just a sphere and the other one is just a rectangular prism. So the Boolean tools can let me do a few different things when I've got two intersecting parts like this. So I can go in here and I can use the union tool if I want to merge these two into a single part. You can see there my part count has gone down to 1. Alternatively, I can use the subtract tool. The subtract is something that I use all the time, both in Creo and in Onshape. I can basically just choose a tool and a target, and it will essentially cut the material from the tool's geometry out of whatever the target part is. You can see that if I accept that, it's actually deleted the sphere, which maybe I didn't necessarily want. If you don't want that, you can just use the keep tools option. Something else that is fantastically useful is the offset tool. So on a sphere, I can either, generally, I can either select to offset all faces, or I can select certain faces to offset. In a sphere, there realistically is only one face, so you can see it's giving me a slightly larger cutout there. And then if I want to use the intersect tool, which is I don't find it to be quite as useful generally speaking, but there are some applications for it. It basically finds the places where there is an intersection of two different parts and it keeps only that intersection there. So there's that. And there's a similar a similar option that we've got here. We can go keep tools, and so then we've created a third part from the intersection, but we've still kept our other two parts as well. So those are the Boolean options. I think to show you a good example of where the intersect tool can be used is this image here. So they've basically just done a revolve there and then kind of a patterned extrude there. They've intersected those two parts and they've been able to make that cool little colander-like dish. It can be really advantageous to try and work out how much your CAD model might weigh in real life. Also having a good understanding of how the mass is distributed, its center of gravity, everything like that. And for some parts, this can be really quite a simple process, like these pure copper bus bars. I can just they have a material of copper and it'll work out using the copper density how much those components will weigh. But for other components like this Energies module here, it's not quite as simple. I don't actually know how much this part, I know how much this part weighs, but I don't know what it's made out of, so I couldn't just input a material or a density. So the way to get around this, when you know the final weight of something, but you don't want to mess around putting a mass and a density in it, you just right click the part and you assign a dummy material. I usually choose something quite light. I'll put in cork for now because it is, once again, quite light. And I'll go tick. Then obviously that'll use an incorrect mass property for that, but I can override it using this display mass properties button. I want to measure that part there, and then I want to say override and say actually this part weighs 0.323 kilos, and done. So now you've overridden what that density calculation was, and you can input directly how much that component weighs. A lot of you will be familiar with the ability to shrink wrap an assembly in Creo, which is where you could basically get an assembly that had a lot of parts and merge them all into one sort of dumb solid so that you weren't carrying around so much unnecessary detail. The connector that I've got in front of me is an example of a place where it would be a really good idea to do that. Generally speaking, I'm not concerned with having all of this detail that's, each and every pin and socket and whatever. It's kind of dumb. So what we can do is we can do Onshape's equivalent of the shrink wrap, which is called creating a composite part. So it combines multiple parts, curves, and surfaces into a single part, and it represents it as just one on the bill of materials and that sort of stuff. So you wouldn't have all of these things showing up on your BOM. So anyway, if we want to do a composite part, here's the tool up here from a part studio. So it wants me to select which entities we want. It would be painful for me to go through and click each of these, so I'll just use the box select. Wonderful. And then this closed option basically allows me to keep kind of all of the detail here, as in it can figure out that there's a whole bunch of separate individual parts and whatever. If I leave it unchecked, then I'll keep all of that detail, or if I hit closed, it'll just merge it all into the one solid, which is probably what we want to do for a part like this. So I'll go OK, and then you can see we've got one composite part there. Takes a little while to load because there's a lot going on. But yeah, so now we can rename that into whatever we want there. Beautiful. Something that you'll come across occasionally is when you'll need to reference something that doesn't seem very easily referenceable. For this example, I've made kind of an interesting shaped loft here, and if I wanted to sketch on this plane and I needed to reference this surface, it's not very clear how I would do that. This comes up, I think, mostly when the aerodynamics team need to kind of do some work with their surfaces. It's referred to as a cross-section curve, I believe, in Creo. But if you want to basically pull whatever the intersection of this profile and this plane is, all we need to do is unsurprisingly use the tool named intersection, and then I select the object that I want to kind of pull the intersection from. And obviously it's going to draw that line wherever this object intersects our sketch plane. And then we can use that either as a legitimate geometry line, or we can use it as construction geometry by pressing Q. My final tip for Part Studio operations is to make use of the transform tool. So the transform tool allows you to translate, rotate, copy, or scale parts, curves, or surfaces all within a Part Studio. So a bit of an example, this is an object that perhaps I downloaded from online, and turns out it isn't in the same scale that I was expecting, but I know I can get one in the right scale. Rather than trying to remodel it myself or anything like that, the transform tool can be quite helpful here. So I can use scale and select that object there. I need to kind of select the origin about which it's going to enlarge. So I can actually pick the origin right here. I can also select significant points or mate connectors. So if I want that to be double the size, it can do that. It can also do non-uniform scaling, so you can do it in 3 different dimensions as well. So we can do some pretty interesting things with the scale tool that can save a lot of time and a lot of remodeling if your downloaded part is incorrect. Anyway, that's all the tips that I've got for Part Studio operations in Onshape. I'll catch you guys in the next video.